We already started looking over chapter 1. When I'm done discussing it with this stats class, for those of you watching the video, I will come back and go over some of the other items that we already discussed. So we're currently talking about levels of measurement. And it's been a while since we did that. So one of them is nominal. Another level of measurement would be ordinal. Okay, what's another level? There's 4 of them. Ratio. And the last one, interval. Okay. Let's briefly describe what nominal would be. What's an example of something that's nominal? It's a name, okay? It doesn't have any order to it. It's just the name, so it's categories, okay? So pets, cat, dog, fish, bird, okay? Ordinal is very similar to nominal, but it's not the same. Yes, it's names that have a specific order. So like the letters A, B, C, D, F, okay? Like if you have a rating system for movies, that's stars, okay? Some sort of order to those categories, okay? Some sort of order to those categories. The next ones are the tricky ones, right? We have our ratio and we have interval, and we know they're both numerical, okay? What is our strategy to remember the difference between those two? Have that, it's using the O in ratio. Okay, so I look at the O and I say O is like 0 and 0 means nothing. So in ratio, 0 means that you have nothing of it. Okay, so if we're talking about the amount of money I have in my pocket right now, it's payday on Friday, the answer is 0. 0 in that instance is a ratio, okay, because I have none. If we're talking about the temperature and the temperature is 0, that's going to be interval, because the temperature of 0 doesn't mean that there's no temperature, right? It means that the temperature itself is 0. 0 has a meaning here. So this ratio, this O right here, means that 0 equals that there's nothing there. Okay? Nothing. Ratio has an O. O is like 0. 0 means nothing. In a ratio, 0 means nothing. Again, I want you to keep in mind, a lot of these problems are going to be matching. It's vocab practice, okay? So you may have, and I don't remember exactly right now if you'd have to write those names in, but it's more likely that these are ones that are meant to go a little bit quicker. You're going to circle whatever it is. I know, for example, discrete, continuous, qualitative. That is definitely multiple choice. Qualitative, quantitative, multiple choice. Parameter versus statistic, multiple choice. And by multiple choice, I mean this one or that one, okay? It's not like random multiple choice. It's like, is it a parameter or is it a statistic? So similarly, see how this says or? So experiment versus observational study. Okay? So what is the difference between an experiment and an observational study? It's been a while. This was the first couple weeks of school. Okay, so it's like a month ago potentially. Yeah.
So observational is like the variables don't change. You just kind of watch what the person does. An experiment, you can change like the variables.
Exactly. Okay, in an observational study, you're literally just watching what's going on, right? You're watching it. You're not influencing anything. In an experiment, someone is influencing something. Okay? Now, also, if you are, like, giving some sort of medication or something, that's technically an experiment. You are giving them something. The person running the experiment is giving them something. If they look back at past data on people who took that medicine on their own and the outcomes of it, that's not an experiment, right? That's an observational study of something someone did way back when on their own accord without experimenter saying you should take this or not take it, okay? So keep that in mind, all right? Observational, there's no influencing anything there. You're just asking a question or observing something. We talked about this next one a little bit yesterday, but we didn't do it on our calculator in this class. We did do it in the other class on our calculator. Are you folks familiar / remembering how to conduct a random sample and or explain a random sample? Maybe, maybe not. Let's grab calculators right now and let's do one. Okay? So what are the steps you took? It cannot be, I used a calculator. Okay, so that's the thing that I explain. Like, I will even tell you what you would have to write to be able to be going in the right direction for that one. Okay? We did have a couple homework problems in section 3 that kind of asked us to do something similar, right? okay, and you're asked to conduct a simple random sample or a random sample of 5 or whatever, okay? What it's asking you to do is select 5 items mathematically randomly, okay? And the way we did that was with a calculator. So the first thing you need to do, and the first thing you would need to explain what you are doing, is create a frame of sorts, okay? You remember the word frame, our vocab term frame? It's when you take your table of data, okay, and you assign each piece of your data a number. So yesterday, or for you folks it wasn't yesterday, the other day when we were looking at your homework assignment, it was yesterday for you, right? We had that table of people and their average pulse rate. And what I did is each of those people I named, or I gave them a number 1 through 9, because there was 9 of them. That is creating a frame. That way when I choose a random number, I know what it references. It's not referencing the exact data, it's referencing a certain location on that table, okay? So that's what a frame is. You have to create a frame first, okay? Then you're going to look at how many items are in your frame. We had 9. They were labeled 1 to 9. You could have 20 items in your frame. You would label them 1 to 20, okay? The reason why that's important is because your next step is picking a seed number. A seed number is where your calculator is going to start looking for random numbers, okay? I would encourage you to pick a seed number that is somewhere within your frame, okay? So somewhere between, for my example, it would be between 1 and 9. If you had 20 numbers, it would be between 1 and 20. It doesn't matter what number you do, okay? So you're going to pick your seed number, and you're actually going to, we're going to start talking about the calculator now, okay? Once you have your seed number, you're going to go to your main screen, clear everything out, go to that home blank screen, and you're going to type in whatever your seed number is. Let's say we were doing, our frame is from 1 to 9, okay? What's a seed number we would want to do? What's a number between 1 and 9? 7. Okay, so in your calculator, you're going to type the number 7. Then you're going to store that number somewhere. So there's a little store button. I want you to look at your calculator. Where's the store button? Yeah, it's like right above the equal sign, right? Okay, so you're going to press your store button. Is it just S-T-R, S-T-O-R? O-R? S-T-O, just S-T-O, okay? And what that's going to appear is it's going to look like a little arrow. Okay, it's going to look and appear like a little arrow. But that's saying we're going to take that 7, we're going to store it somewhere. Now you need to tell your calculator where you are storing the seed number. We want it to be stored in our random sample spot, right? That is not under stats. We've been doing a lot of work under stat, right? This is instead on the left-hand side under the button Math. So you're going to click Math. And technically, when we're randomly selecting something, we're using probability, aren't we? So we're going to go all the way over to where it says PRB. Okay. Under PRB, you see it R-A-N-D, right? Rand, which is your number 1. And then you're going to press Enter. Okay. So now it should say 7, arrow, rand. You need to press Enter again. That way, it shows the 7 on the side over here. It means that it stored the 7 under rand. If you never press Enter, you never actually store it. So has everyone pressed Enter? And then the 7 shows up on this side now. Okay? Now you're ready to actually calculate your random numbers. So you're going to go back into your math menu. Okay? So now your next step is to actually get your random numbers. Find numbers. Okay? You go back into math. You're going to go back into probability, PRB. And now you're going to go down to rand int. And you're going to tell the calculator which interval to pull random numbers from. Because if my frame only goes 1 to 9, I don't want to pull up the number 25 or 2,873. Do you see what I mean? Like it has to fall somewhere between 1 and 9. So once you click Enter on that, it's going to say on your screen, rand int, open parentheses. You're going to put the first number in your frame, which is usually 1, right? You'd start numbering at 1, comma, the highest value you have in your frame. Again, if my frame went up to 9, I would put 9. If your frame that you created went up to 20 or 30, you would put 20 or 30, whatever it is, and then close your parentheses. Once you close the parentheses, and I don't think you even need to close the parentheses, once you press enter, it will pop up a random number. And when you press enter again, it will pop up another random number. And if you press enter again, it will pop up another random number. So if you need 5 random numbers, you're going to press enter 5 times. What happens if you need 5 random numbers and they tell you each person can only be selected once? What happens if you get the number 3 twice? Just hit enter again and get a different number. Okay? And that's how you're going to randomly select an item. Your description should not be, I'm going to use the random number generator on my calculator. If you are describing or explaining how you did that, you're going to say, I first created a frame by blah, 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 blah. I then chose the seed number, whatever. If you don't tell me your seed number, I can't check your answer. Does that make sense? Okay? If you don't tell me your seed number, I don't know what to plug into my calculator because everyone's going to have potentially a different seed number. I won't know if your answer is right or wrong. You have to tell me that, okay? And then you can say, after plugging in the highest and lowest possible values, I got my 5 things. You don't have to say, I pressed enter. I pressed enter. Obviously, okay? But you just give me as much information so that you feel like, okay, Mrs. White's going to know exactly what I did and that I know what I'm doing, okay? It's a test. Don't say, I think this is good enough. Be like, I know this is good enough right now as far as my explanation, okay? Is that some clarification on that process? Other questions about it? All right. Next, there are sampling strategies, and it's been a while since we talked about sampling strategies. I would encourage you, okay, to take a look in your book and go over those. Okay, so we do have our random sample. Other sampling strategies include convenient sample, which is not good, right? If it's convenient for you, it's not giving you super great data. You have a systematic sample. Okay. What is a systematic sample? What's our brief description of systematic sample? You have some sort of system that you're following. It's when you select every kth number. So I would encourage you to take a look at the problem on your Chapter 1 quiz that is similar to that, because that's definitely could be a thing. Okay? So I'm serious. I want you to look through those quizzes, look through those homeworks, especially when it comes to these sampling strategies. I'm not going to go into depth. We don't have time to go into depth about all of them. Okay? But the systematic sample, that's your case 1. You have to figure out if you want to, for example, if your population is 8,000 and you want a sample of 100 people, okay? You need to be able to figure out what your kth value is. It's very simple. Okay, look that up. And then you start with some seed number, kind of, right? That's between 1 and your first value, your first K. And then you just add that same amount every single time. Okay? It is not random number selection. Okay? Systematic is not random. It feels random, but you're actually picking every 32nd person, starting at 5. So it'd be 5, and then 38. And then I continue adding 32 to it every single time. Okay? And then your other option would be a stratified sample. And a stratified, it makes me think of rocks, right? Okay, we have different layers to it. You're going to have different groups, and then you're going to take a few from each group. And in a cluster sample, which is very similar to stratified, right? You have lots of groups, but you take the whole group. Okay? So those are our sampling strategies you should look at. Random sample, which we just went over. Okay? You should be looking up a systematic sample, stratified sample, and cluster sample, and be familiar with what each of those are. There's also bias types. That's an activity we did where you read over like either a response or a non-response bias sheet, and then you got together and talked with other people. Okay? So there's a handful of bias types. I would maybe read over those and be just familiar with the names. Okay? And I felt like you guys did really good with misleading graphs. We had a really good class discussion on that, so I feel like the 1 or 2 questions you have on that, you're going to be set with. Okay? Make sure we're looking at the scales, looking at your y-axis, right? If that y-axis doesn't start at 0, it could or have a break in it, it could be misleading. All right? So look over those notes. And then the last thing is experiment types, which is right at the end of Chapter 1. Okay, so what are all the different types of experiments? And they're very similar to sampling strategies. A couple of them feel similar. Like you have the blocked experiment, okay, and you have a random experiment. you want to take a look at those and make sure you understand the difference. Okay? Y'all have books, so I would take these items and I'd flip through the chapters when you're studying and look over, okay, Mrs. White said I need to know experiment types. It's written on my list. I want to go to that section because I'm not 100% on that. Look it over and write myself a couple little notes. Okay? Use the textbook. Use that book. So that's going to bring us to the end of chapter 1. Okay? And I did on the side put a little assignment there. You do not have to do it. I'm never going to check it off. I'm never going to look if you did it. But if you look, starting on 54, it does say chapter 1 review. I don't think you should do all of that, but like some of the ones where it has you choosing between qualitative or quantitative, like you can just read those over. They're examples. Or you can look over homeworks that we've corrected together. You can go to past notes from past classes and look over those too. There's lots of materials that you have available to you. Okay? All right, let's move forward and talk a little bit about chapter 2. So that's going to be the second section on this exam topic sheet. And this one had a buttload of graphs, like just so many graphs, it was crazy if you remember. Okay, lots and lots and lots. I'm not requiring that you be able to make lots and lots and lots. I've listed the ones that you need to know. Okay, so frequency and relative frequency distribution you need to be able to do. Okay, so those are our tables, right? And if it's relative frequency, remember relative frequency means we're taking it out of the whole, we're finding that decimal value. Frequency distribution is just saying how many are in each category or each interval. We call those classes, right? There's potential that you're going to be asked to create, just like on your chapter 2 test, a table with a class width of 4 or 5 or whatever. Biggest mistake people were making on that chapter 2 quiz was you were setting up your classes incorrectly. Okay? If I say a class width of 4, that doesn't mean you do 1 plus 4 is 5. I'm going to go 1 to 5. That's actually a width of 5 because it includes 1, 2, 3, 4, 5. See what I mean? That's not a width of 4 because it includes the 1 in it. I don't know if you're following what I'm saying. Like 1, if I were to make a interval of 1 to 5, okay, you might think that's a width of 4 because when you subtract them, it's 4. It is not. The numbers that could fit in this interval are the numbers 1, 2, 3, 4, and 5. It actually is a class width of 5. So be careful when you are, that's like the biggest bummer on that quiz was that people set up that table wrong, and I was kind of nice on the quiz. If you set it up wrong, but in the second problem you stuck with your error, I didn't actually take points off on the second problem. I said, oh, this is right based on the error you made on the previous problem. And then you made a histogram, and I said, oh, well, maybe I'm going to give you a good portion of stuff for this because you still made that table wrong, which then you made the histogram wrong. Do you see what I mean? It became like 3 or 4 problems. I didn't want to kind of like kick you on the gut there, okay? But you need to make sure you are setting up those class widths correctly. Head notes that you kind of get what I'm saying here with our group data, okay? If not, pop me an email over the weekend and be like, I'm still confused about that, and I'll try to text it to you if I can, okay? Pop you an email back. Next, these are the ones, and I didn't put anything except for their names. These are the ones you need to study, know how to create, know how to read, etc., from section 2. Bar graphs. Do the bars touch in bar graphs? No. Okay, and they measure categories. Histograms. You need to know how to create a frequency and a relative frequency histogram. Okay? Similar, you need to be able to do a frequency and a relative frequency bar graph. The only difference is a bar graph on the bottom is categories. Okay, the bars don't touch. And a histogram across the X is going to be numerical data, and it can look 2 different ways. If you have grouped data, you don't put this interval across the bottom. You set up your x-axis with your bars that touch, and you label in between the bars. So if my interval was an interval of 5, like this, I would put 1 here. My next bar doesn't start at 5. My next bar would start at 6. And then my next bar for my next interval would start at 11. And I do the height of each of these intervals in between the bars like this. Okay? So remember, you're labeling in between those bars if you have an interval. If you have numbers, but they're not showing a span of numbers, if it's not with a dash, no interval, no group data, then you just put the number in the middle. If this shows all of the number 1s and then all of the number 2s and all of the numbers 3s, you put it in the middle. If it's showing a span, you put them on either side to show that the bar covers everything in between those. Okay? So that's the difference with histogram, stem, and leaf plots. You guys have that on a quiz, and you have it in homework, so I'm feeling okay about that. Make sure, and I was not picky about this before, I will be picky about it on the test, you must include a legend. Okay, stem and leaf plots. Maya, question.
Wait, so when you put 1 and 5 on the lines?
So are we talking histogram right now?
Yeah.
So in a histogram, it's numerical data. Okay, your bars should all be touching. All right. If you're dealing with grouped data, so if it's an interval, if it goes 1 to 5, and then it would have to go 6 to, it looks like we added 4 here, so 6 to 10, and then our next one would be 11 to 15. Okay, if those were our intervals with our frequencies in them. Because they're intervals, I label the lines between the bars. Because this amount of data is in between 1 and 5, right? So I start with the 1 because that's where my data starts. And I'm not going to label this 5. I'm going to label it where the next one starts, 6. And then this bar, if it has a frequency of 3, is going to be 3 high. This bar starts at 6, goes to 10. The next one starts at 11, so I would label this 11. And maybe this has a frequency of 1. Okay? If it's set up with intervals, you label in between, or you put your bars in between each of the labels. And the labels are your starting point for each of the intervals. If you don't have group data like that, if they're just solid numbers, everything that's 1 or 2 or 3 or 4, then you can label them in the middle. But otherwise, you should not be. Let's go back to stem and leaf plots. I want you to put a note on there. Double check that you know how to make a legend. Okay? Because I did not double check that on the quizzes. And I felt really bad after I had corrected a bunch and put them in. And then I was like, oh, some of those are missing legends, but I already put their grade in, so I didn't change it. Okay? Make sure you know how to create a legend for a stem and leaf plot. And then you have dot plots. Pretty straightforward, too. Did I pass back your chapter 2 quizzes yet? Okay, so some maybe have it, maybe some don't. They've been in the box. I have them for you. You can grab them. My goal would even be that, and I don't think it's going to happen based on the time, I was going to try to correct your chapter 3 ones while you were in class to get them back to you today. But if I'm not putting them in until tomorrow, then I can't. Do you see what I mean? I can't get them back to you in class today. So we'll see what's up. So aside from reading and creating these graphs, I want to point out to you, it does not have a frequency polygon. It does not have a no-give, okay? It does not ask you about cumulative frequency. It does not say on it pie chart, okay? So those are things, I want to be honest with you, you might have to read those graphs, but I'm not going to ask you to create them, so I don't want you to spend a lot of time studying them. Comprende? So next is describing spread. That's uniform, bell-shaped, skewed left, skewed right. We talked about that a little bit yesterday, okay? We talked about that a little bit yesterday when we looked at box and whisker plots, but those are also applied to these same types of graphs, right? Skewed left, skewed right, uniform, or bell-shaped. Mean, median, mode, and range should be in a different section.
They are.
They should be in chapter 3. They're in there twice. Or did I just accidentally have it on this twice? Oh, I split it up wrong. So yeah, that's the end of chapter 2, I guess. Okay, but I guess I took a screenshot wrong here. Questions on chapter 2 stuff. That is definitely slimmed down a lot from all the stuff that was in chapter 2. Every day we were doing graphs and graphs and graphs. It was crazy. Okay. So now, even though it's not on the right one, let's start talking about chapter 3. You need to be able to do mean, median, mode, and range. Okay? Mean is the same thing as your average. Add them all up and divide by how many. If you are doing the mean of grouped data, you need to find your midpoint and then your frequency, and you need to use a calculator. I'm not going to ask you to do any of these calculations by hand. You're all going to have a graphing calculator sitting on your desk. Okay? So you just need to know how to do it. So again, if it's group data, your L1 is your midpoint. Your L2 is your frequency. Okay? If you're doing normal mean, you can add them all up on your calculator, but you could also put them in a table, right? Have them in your L1 and do the same thing, one variable stats. Next, we have standard deviation. I want to underline the difference between sample and population. You're not going to be changing the formula yourself, okay? Because you're going to be using a calculator. Again, I'm not going to make you do these by hand. I don't care anymore. We're going to use standard deviation so much in this class that there's no reason for you to do it by hand. I want you to understand what it means, how much work it is to do by hand, so you're like, I'm so glad this calculator exists. I don't want to have to do this by hand. Okay? And you do need to know, be able to tell, just like from chapter 1, if it's a sample or a population. If you don't know which one it is, that's going to be rough, because you're going to use the wrong number. Then I'm going to mark it wrong. Okay? So take your time and ask yourself that clarifying question every time. I put stars next to this because you're asked a question of this, and I did not. Degrees of freedom. Okay? So, and I maybe mentioned it briefly once. Degrees of freedom only happens when you're dealing with a sample. Okay? And the degrees of freedom is the denominator of the standard deviation thing. So essentially, it's your lowercase n minus 1. So it's the amount of people in your sample minus 1. Okay? So if we think back to that frame example, right, with pulse rate where we had 1 to 9, if that was a sample, our degrees of freedom, there's 9 people in it. I minus 1, my degrees of freedom is 8. Okay? It's just a fancy way of saying the denominator piece that would be for a sample. You cannot have degrees of freedom if it's a population. Okay? It's just how many people are in that group minus 1. It's called the degrees of freedom. That one is like, I had guilt when I saw that on there because I didn't spend time talking about it in class, but that's pretty straightforward, so I'm guilt-free now. Okay? Next is the empirical rule, and this one I want you to really understand and look at. That's the one where we look at our normal curve, right? Where we have this. In the middle is going to be our average, so it's either our mu or it's our x-bar. Then we look at standard deviations above and below. My advice to you would be, and we talked about this last time, set up one of these with all of your numbers, right? If your average is 20, put a 20 here. If your standard deviation is 5, go 5 above, 5 above, 5 above, go 5 below, 5 below, 5 below, and then fill in your percentages. Does anyone remember what the groupings for percentages are? I've said them a lot, but I've not made you say them. One standard deviation in each direction is going to be, 68, good. So from here to here is 68. Two standard deviations out in either direction. So from the 10 to the 30 would be what? 95. And then the last one is almost everything. 3 standard deviations out should be 99.7. 99.7. So if those aren't in your head, and this idea of this graph is not in your head, I would put it in there. Okay, that's something I would draw a couple times and study. 68, 95, 99.7. And then from there you can figure out, okay, if this is 95, from here to here, this amount then, just this little bit above, is going to be half of the 5% left over, 2.5%. So on and so forth. Then we have z-scores, which this is the stuff we talked about this week. Z-scores is how you measure and compare things that are in different groups. Okay, so we had our 2 baseball teams in the American versus the National League. We had the 2 babies' weights we were comparing. One of them was born like a month and a half early, and the other one was born on time. We can't compare their weights to each other. We need to compare them in their respective groups, and we do that by doing z-score. Okay? What's the general formula for z-score? What do we do? It's only 3 numbers. It's x. So whatever your point is, the data for that initial thing. It could be mu or x bar. It doesn't matter. It's going to be your average, whichever it is. And what do we do between this point and our average? Yeah, x minus, we'll just say it's a sample. So we'll say it's x bar. And after we've subtracted the average, we divide it by your standard deviation. And remember, if you're dealing with samples, standard deviation is S. If you're dealing with population, it's that sigma, right? It's that little O with a little line on it. Okay? And z-scores are to be able to compare things that are in different groups and be able to tell, like how are they related to their own individual wholes so you can compare them in a way that makes sense. Next we have percentiles. I feel like y'all were pretty good at that. Remember, if you're in the 80th percentile, that doesn't mean you got an 80%. It means 80% of people did worse than you and or as good as you, and 20% did better. Okay? It's your position. All of these have to do with positions. Okay? It's your position out of 100 people. Where would you be? You're in the 80th percentile. Okay? Not what you earned. And lastly is going to be box plots. You need to be able to calculate a 5-number summary, minimum, first quartile, median, third quartile, and maximum. You need to know how to calculate for outliers. Okay? So that's 3 steps. Make sure you study those. So you find your IQR, times it by 1.5, add it and subtract it. And then lastly, you need to be able to describe and read box plots, and describing them is skewed left, skewed right, or symmetric. There's no bell curve for that, but it's those other 3 terms. Okay? Skewed left, which means all your data is on the right, it's skewed to the left. Skewed means spread out. Okay? Spread out on the left, spread out on the right, or symmetrical. I know there's a lot of stuff, but I'm hoping the items that at least we've done in chapter 3 are going to feel more natural to you, and you're going to have to spend time really just studying stuff from the middle. I'm feeling like sampling strategies might be something we need to look at. It's been a while, okay? Types of bias, maybe make yourself some flashcards, okay, of those vocab terms if they're going to be hard for you. Questions for me right now. We have about 20-ish minutes left, a little bit less than 20. Good? Okay, so what I want you guys to do is take a look through your book. Because we're recording right now for the other class, I do want to go back to chapter 1 and just talk to them about the first 5 bullets or so, which is going to be a repeat for you. So I want to make sure they have that as a reference because I'm not here tomorrow. And you guys can go into those. I'd probably start out right in chapter 1. I'd go right to page 54 and probably look over those problems. And if you're not sure which one's which, okay, lean on a friend, write yourself a little reminder, okay? So those of you who are still listening, we're going to go back to that first section. I had forgotten to record until we got a little bit into our lesson today. So I want to make sure you guys get the same support that these folks did. So looking at our first chapter section, we did talk a little bit about population sample individuals. I know we've talked about that a little bit in class recently, so I'm hoping there's not as many questions. If we're talking about maybe gathering information about Winthrop High School, the population would be all of the students in the school. The sample would be maybe 2 or 3 people chosen randomly from each advisee group, and then the individuals are going to be each of those people that you actually ask. So being able to delineate between population sample and individuals, and maybe determine when you're dealing with a population versus a sample. Next, we have parameter versus statistic. And I'm sure you can see from the arrows that parameter is just some sort of data point that's describing a population, and statistic is going to be describing a sample. So if you say you actually survey the entire school, or you look at the grades for everybody in the entire school, and you see that 90% of students at Winthrop High School are passing, if Winthrop High School is your population, that's a parameter. If you only survey 20 random people, okay, so you do a simple random sample, and you say, of the people that were sampled at Winthrop High School, 75% of them are passing, that would be a statistic because it's describing that sample. So you really want to be careful and read and think about, is this a sample or population when you're answering that question. Next, we have qualitative and quantitative, and I know we talked a lot about this when we did chapter 2, okay? Qualitative is measuring some sort of quality or a category. And quantitative is how many, how much. So quantitative has to be numerical. Now, qualitative can be numerical. We spoke about that here, okay? If those numbers are describing a quality and not an amount, then it's still qualitative. So for example, if you think of like area codes when you call places, Maine is 207, right? Even though 207 is a number, it's actually describing a quality. It's describing a location. So 207 would be qualitative versus quantitative. It's not saying how many or how much. And the last thing we talked about before you folks joined us was discrete versus continuous. And this is going to be a multiple choice question that they actually threw qualitative in there. So first things first, it's probably going to be a numerical question, right, if they're asking you discrete, continuous. But remember, sometimes numbers can describe a quality, so keep that in the back of your head. Discrete items cannot be broken into smaller pieces, so things like school buses, amount of people, things like that have to be whole numbers, where continuous items can be broken into smaller pieces and actually make sense. So the weight of apples when you go to Hannaford, things like that can be broken down into smaller pieces. Time can always be broken into smaller things. So that generally is going to cover all of the items that we're going to be looking at for the assessment. If you have any questions, I know those of you that are listening right now are probably a little nervous because I'm not there. Feel free to request me for Win on Monday. You folks are fortunate that you get that little extra time. So please, please, please be proactive. And by request me, I mean let me know that you want to request me so I can outline some time for you and not just grab a bunch of Algebra 2 students instead. Also, over the weekend, feel free to ask any questions. I will try my best to get back to you as soon as possible. No homework assignment related to this, folks. I just want you to prep, be ready, do well, use your textbook, use your quizzes, and use your notes. I will have those quizzes corrected and waiting for you Monday morning if you're interested in getting your Chapter 3 quiz back as soon as possible. Thank you, folks. Good luck, and I hope studying goes well.